The James Webb Telescope has proclaimed the most clear image of Proxima B in history, uncovering stunning disclosures concerning this possibly tenable exoplanet. Go along with us as we leave on an endeavor through space to uncover the privileged insights of Proxima B and check whether it very well may be the following Earth we should wander into the tremendous territory of room where a strange planet exists in a livable zone of its star Proxima Centauri. This planet isn't any standard stone. Its world's cousin Proxima B, found 4.2 years away, it is covered in secret and miracle. It at any point sometime or another be one more Earth with seas and life overflowing on its surface. Yet stand by, there's more. Proxima B isn't the only one circling the red small star. It has a solitary friend, Proxima Centauri Ocean, which might uncover significantly more mysteries. Maybe there's another friend yet to be found. The secret doesn't end there. Proxima Centauri B gets almost similar measure of energy from its star as Earth does from the sun. Could this mean there's water on its surface? Maybe life, as far as we might be concerned, could exist past our nearby planet group. As we venture farther into space, we experience another universe of exoplanets, planets that circle stars other than the sun, with 20,000 billion stars in the smooth manner world alone. The opportunities for exoplanets are unending. Some even float through space, untethered to any star like maverick pilgrims among them. Proxima Centauri B stands apart as a genuinely dumbfounding planet with a year enduring just 11.2 Earth days. Its separation from its star is a lot nearer than Earth is to the sun. Thus one side of the planet is interminably washed in light, while the other remaining parts in everlasting murkiness. Presently, how about we look at Proxima Centauri, the star around which Proxima B circles. Proxima Centauri is essential for the Alpha Centauri triple star framework. This framework incorporates Alpha Centauri N and B2G and type stars that show up as one in the heavenly body Centaurus and are the third most brilliant stars in our night sky. Proxima Centauri, additionally called Alpha Centauri C, is a red diminutive person or type star found 4.24 light a long time from the other two stars, making it the nearest star to our nearby planet group. The name Proxima Centauri implies the closest star of Centaurus. In Latin, it was found in 1915 by Scottish cosmologist Robert Thorburn. In spite of being the nearest star to us, Proxima Centauri stays undetectable to the because of its application extent. In addition to 11.13, a long ways past the natural eye's cutoff of 6.5. Don't let that fool you. However, Proxima Centauri is as yet a star worth concentrating on. Red small stars like Proxima Centauri are among the most effective as far as energy creation. While they may not produce a lot of light, the inward convection process at their centers permit them to sparkle for trillions of years. As a matter of fact, Proxima Centauri will stay a principal sequence star for one more 4 trillion years anyway. The tenability of a red bantam like Proxima Centauri is as yet bantered. For one, it's a flare star, which implies it undergoes successive and erratic ejections. As a low-mass star, its livable zone would be a lot nearer to it than the sun's, likely somewhere in the range of 0.23 and 54 pennies. Yet it's not quite so welcome as it would appear. Proxima B might not have a steady air. Okay, I understand what you life would be helpless against outrageous space weather conditions, making it almost unimaginable for it to flourish. So while Proxima B could appear to be Earth-like on a superficial level, it's a long way from fit for supporting life. The mission to uncover reality with regards to Proxima B going with some actually holding out trust. One instrument that has caught the consideration of cosmologists is the James Webb Telescope. After a few defers, the telescope was at last sent off in 2018. It can possibly decide if there is life on Proxima B. Anyway, likewise with everything in science, things are never all around as direct as they appear to be. Various changes were important to guarantee the James Webb Telescope could convey precise pictures. As Abby Wind, a hypothetical physicist at Harvard, makes sense of assuming that a planet like Proxima B ingests light from its star, it can likewise re-emit that light as infrared radiation. The James Webb Telescope was explicitly intended to distinguish infrared light. It can catch pictures of this radiation from the planet's surface in quest for designs that could affirm whether the planet has water or an air. Yet imagine a scenario in which the planet's air isn't appropriate for life. The presence of an Air doesn't ensure the presence of life. Cautions Ed Turner, an astrophysicist at Princeton College. Proxima B could be like Venus with an air a lot denser than Earth, subsequent in outrageous intensity. That would make life unthinkable. The mission to cover the privileged insights of Proxima B isn't without its difficulties. While the James Webb Telescope holds guarantee, there are numerous factors to consider with costs mounting. Space researchers are feeling the squeeze to sort out some way to concentrate on planets like Proxima B. The dangers are extraordinary, yet the prizes are much more prominent. The opportunity for a brief look into the obscure and the chance of finding a far-off planet that could hold on to life. Might we at any point even travel to Proxima B as the nearest exoplanet to us? It's thrilling. It's practically similar to investigating our cosmic patios, considerably seriously entrancing that it's almost a similar size as Earth. Its situation in the tenable zone implies it might actually have conditions for life as far as we might be concerned. Proxima B's closeness likewise makes it a suitable objective for our quest for life past Earth. At 4.2 light-years away, it's an ideal contender for interstellar missions. Really ponder the chance of investigating this Earth-like exoplanet anyway. We can't arrive right presently, still it's surely on the radar for future missions. As innovation progresses, making it more open, it's perhaps of the most fascinating chance in the field of room investigation. Yet it's no straightforward undertaking. To arrive it would require 75,000 years for space apparatus like Explorer 2 to arrive at the Proxima Center framework anyway. An arrangement has been proposed including sun-oriented sails, ultra-slim sails that could speed up a space apparatus to the Alpha Centauri framework in Proxima. Alongside it, this innovation utilizes sunlight-based strain to keep the rocket on course, disposing of the issue of running out of fuel with extended paces of 10% to 20% of the speed of light. The excursion to the Alpha Cent framework could be diminished to only 20 years. The revelation of Proxima B has reignited humankind's revenue in space investigation. It has provided us with a newly discovered feeling of trust that we are in good company in the universe. The James Webb Telescope is a wonder of current innovation, fit for taking us as far as possible back to the earliest reference point of the universe. 13.7 quite a while back. This cautious perception divulges secrets, helping us to remember the vast miracles of the universe. The James Webb Telescope's capacity to look into the universe's earliest minutes and inspect planets like Proxima V denotes a fantastic jump in mankind's journey to comprehend the universe. With its cutting-edge innovation, the telescope can examine air structures, recognize synthetic marks, and even quest for biomarks and signs of life that could exist in the airs of far-off planets. Yet the investigation of Proxima B goes past mechanical wonders. It's tied in with responding to key inquiries. Are we alone? Might life at any point exist somewhere else? What does this enlighten us regarding our spot in the university's inquiries have driven humankind's interest for a really long time, and Proxima B with its Earth-like characteristics addresses quite possibly of our most encouraging lead difficulties in concentrating on Proxima B. While the telescope offers uncommon bits of knowledge, it faces limits. For instance, the nearness of Proxima Centauri B to its star implies it's continually presented to heavenly flares. These flares can strip away airs or assault the surface with radiation, possibly making the planet dreadful. The telescope should represent these flares while dissecting the planet's current circumstance, furthermore identifying indications of something going on under the surface on Proxima B is muddled by its expected flowing locking on the off chance that one side of the planet generally faces its star. The day side could be incredibly warm while the night side may be freezing cold. This lopsided dispersion of temperature could make outrageous weather patterns. Testing the presence of fluid water a vital element for life. Future missions and advancements. The investigation of Proxima B has motivated new mission ideas. Among these is advancement Starshot, an aggressive task that means to send minuscule light fuel shuttle to the Alpha Off and Pinnacle framework. These space apparatus furnished with cameras and sensors could go at 20% of the speed of light, decreasing the movement time to only years and years. Researchers are additionally investigating the chance of bigger unrefined missions in the far-off future. Such missions would require progressive headways and drive life, emotionally supportive networks and energy assets, the advancement of combination motors or antimatter. Impetus might one day at any point make interstellar travel plausible, making the way for investigating Proxima B in past. Proxima B in the quest for life. Regardless of whether Proxima B ends up being appalling, it actually holds important illustrations about exoplanets and their surroundings. It serves as a stepping stone for studying other potentially habitable worlds. Currently, astronomers have identified thousands of exoplanets, many residing in the so-called Goldilocks zone of their stars, where conditions might be perfect for life. The discoveries made while studying Proxima B also contribute to the broader understanding of planetary systems. For example, learning how planets form, evolve, and interact with their stars can help refine models of planetary habitability. This marks a new era of exploration. The discovery of Proxima B has reignited humanity's dreams of interstellar exploration. While challenges remain, every step forward brings us closer to unlocking the mysteries of the universe. From telescopes revealing distant worlds to spacecraft that might one day visit them, we are living in a golden age of discovery. Proxima B reminds us of the vastness of the universe and the unimaginable possibilities that exist within it. Whether life exists on this distant world or not, its presence challenges us to dream bigger, explore further, and continue seeking answers to the mysteries of the cosmos. Let me know if you'd like to delve into a specific aspect of this, or if you have another direction in mind. It takes light years to reach us, which implies that the James Webb Space Telescope can observe objects in the universe farther away than any telescope before it. Moreover, it can detect these objects in longer wavelengths of infrared light, allowing us to see more distant stars with greater clarity than ever before. And guess what's even cooler? This incredible technology can reveal insights into the possibility of life on other planets, such as Proxima B. However, as with any groundbreaking discovery, there are challenges. The presence of an atmosphere doesn't necessarily guarantee the presence of life. Proxima B could be like Venus with a thick, harsh atmosphere, yet the James Webb Telescope can detect such atmospheres if they reach a brightness of just 5% of the planet's day side. While 5% might not seem like much, it's significant when dealing with a star that is typically dimmer than our Sun. If Proxima B has an intelligent civilization, they could potentially be using bright orbital mirrors to reflect sunlight from the planet's day side to its night side. How fascinating is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being massive gas giants while others resemble Earth. One type of exoplanet that has caught the attention of astronomers is the gas giant. These planets are similar in composition to Jupiter and Saturn, but are much larger. Some of these behemoths have been dubbed super Jupiters, surpassing even the largest planet in our solar system. But that's not all. There are also hot Jupiter's gas giants that orbit extraordinarily close to their host star. They exist in a searing environment with temperatures high enough to melt metal. Imagine being able to observe such a planet up close with its violent storms and extreme heat. In addition to gas giants, there are also Neptunian exoplanets, which are similar in size to Uranus and Neptune. Among these are warm Neptunes and mini Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, making their atmospheres difficult to study from afar. Let's not forget terrestrial exoplanets, those that resemble Earth. These planets come in various sizes, ranging from smaller than Earth to twice its size. There are also super-Earths, which have masses greater than twice that of our planet but are lighter than Neptune. One of the most intriguing exoplanets discovered recently is Proxima Centauri B, which orbits the star of the same name. This planet is classified as its super-Earth, with a rocky mass 7 times that of Earth. Despite being close to its host star, it is still too far away to be considered within the habitable zone. Proxima Centauri B is not alone. It has a companion, Proxima Centauri C, which orbits farther from the star. This planet has an orbital period of around 5 Earth years and was discovered in 2020 using pre-recovery Hubble data. Even more fascinating is that Proxima C appears unusually bright, possibly due to the presence of a ring system. There are more discoveries to be made in the Proxima Centaur system. In 2019, astronomers detected a change in the star's rotation rate which could result from another planetary companion. If confirmed, this planet would be named Proxima Centauri and would be roughly the size of Mercury or Mars. Imagine a reality where the night sky is filled not only with stars, but also with countless other planets, each with its unique characteristics and orbits. The universe is full of surprises, and exoplanets are just one of them, with new discoveries being made constantly. It's an exciting time to astronomer. While we don't yet have an exact count of exoplanets, we know they exist in abundance throughout the universe. However, exoplanets are not easily observable. It takes advanced technology and powerful telescopes to detect them. These planets are often obscured by the brightness of their host stars, making them challenging to study. Yet with advancements in technology, direct imaging of exoplanets is now possible. For an exoplanet to be directly imaged, it must be large enough to be visible to the telescope, far enough from its host star to avoid being overshadowed by its brightness, and young enough to be hot and visible from Earth. These requirements limit the number of exoplanets that can currently be directly imaged, but offer a fascinating glimpse into the properties and composition of these distant worlds. Exoplanets are typically found through the effects they have on their host stars. The gravitational pull of an exoplanet can cause its host star to wobble, and this change in the star's motion can be detected by astronomers. The Kepler Space Telescope used the transit method, which measures the dimming of a star's light when an exoplanet passes in front of it. This method has provided a wealth of data about exoplanets, including their size, distance, and temperature. Here are a couple of fun facts. Did you know that more than 22% of stars like the Sun have Earth-sized planets in their habitable zones, or that the TRAPPIST-1 system is home to 7 rocky exoplanets with water on their surfaces? Exoplanets in our solar system can also have natural satellites known as exomoons, with more than 4,000 exoplanets discovered so far. We know they exist in abundance throughout the universe. Hot Jupiters, with their massive size and rapid rotation, are the easiest to detect, but there are countless other exoplanets waiting to be discovered. NASA's James Webb Space Telescope is unlocking the secrets of the universe, one discovery at a time. The telescope has been gathering data and capturing stunning images of the cosmos, revealing previously unknown wonders. Recently, it made a groundbreaking discovery that will forever change our understanding of the universe.